I'm Anil Kumar, and in this video we will explore the increasing and decreasing interval of a function. So we have taken a cubic function to start with. Whenever you want to find the interval of increasing or decreasing, you have to see the function from left to right. That is kind of important to understand. Otherwise, it is sometimes very confusing. So always see your function from left to right. So that is the left position, which is from minus infinity to right, which is plus infinity, towards plus infinity. So the x value has to increase or move towards the right as you look at the function. Now, at the function, mark the turning points. So in this function we have two turning points, and let's give some numbers to it. Let's say P and Q. So these are the turning points. Of course, at the turning points, the function is changing from either increasing to decreasing or from decreasing to increasing, right? As you observe here, if you move from left to right till P, the function is increasing, and from P to Q, the function is decreasing, and thereafter it is again increasing. You'll also observe that the point at which a function turns could be a maximum or a minimum, a local maximum or a local minimum. Now, if we have to really define intervals of increasing and decreasing, then what we do is we see the continuous part of the function. In this case, the function is all throughout continuous, right? So the function is continuous, so there is no problem. In the whole interval, we can take any points. But if we have a function which is not continuous, let me take one example here. For a function which is not continuous, so we can discuss both the things together. Let us say we have a function here which is kind of like this, and is discontinuous at a point, and then again it is kind of like that, right? So if we take a function which is discontinuous, then we have to take into consideration the point of discontinuity also. So when you mark the points, mark the turning points, for example P and Q, right? This is also a turn, and also the points where the function is discontinuous. So let us say these points are R and S. And then have a look at the function, correct? So that is how you can easily find increasing and decreasing intervals. Now, let's review both these functions. For the first function, let us find the interval when the function is increasing. Now when we say increasing, it means what? Increasing means if I take any 2 points, let us say my points are A and B. So at A, the value of the function is fa. So here the value of the function is fa. At B, the value of the function is f of b. Now for increasing, if b is greater than A, then f of b, the value of the function at b, should be greater than value of function at a. So that is by definition increasing, and makes sense, right? So if you observe from minus infinity to p, the function is always increasing since the point on the right side has a higher value, right? So b is a point on the right side on the curve. So we'll say the increasing interval for our function, the first function given to us, is from minus infinity to p, right? So let me call this point as small p, right? So from minus infinity to p, the function is increasing. And thereafter, it decreases till q. So we can say the decreasing interval for this function is from p to q, right? So we say p to q, it is decreasing. So that is q value, the x value, x coordinate value for point q. Now after q, which is a local minimum for the given function, the value of the function again increases. So we'll say, and again it increases from q to infinity. So that is how you can write increasing and decreasing interval for a function. Now let us do the same thing for a discontinuous function, right? So here we'll follow the same policy and then see how it works. So here it increases from what value? Can you help me? From minus infinity to p, right? So let me say it increases from minus infinity to p, and then it decreases. So the decreasing interval will be from p to r. So let me use lowercase for x coordinates, right? And then there is a discontinuity. From S to Q, it is a horizontal line. It is neither increasing nor decreasing, right? So that is not within our increasing and decreasing interval. It is constant from S to Q. However, after Q, the function is increasing. So the increasing interval is also from Q to infinity, right? So that is how we can find increasing and decreasing intervals for any given function. Remember, whenever you're looking at a function, see from left to right. So if you see from left to right and mark the points where we have turning points in the function, then it's kind of easier to find out increasing and decreasing interval of any given function. I hope that helps. Thank you.